I know what else I was going to ask. The other thing I'll say is, aside from the first page here, do make sure you show your work. I want to see your thought process. If you don't get the answer right, that's totally fine. I want to see how you got there, because usually there's a lot of partial credit to be given. I'm definitely in the business of trying to give partial credit for work that makes sense. So please, please, please show your work. Answers that are right, except on this first page, that don't have any work supporting them, will receive little to no credit. So I really, really want to see that you understand what's going on, not just that you can find the right answer. Okay, I'll try to be relatively reasonable. Like some things, yes, I know you just know that this thing is like, if I wrote down like log base 7 to 49, I don't really need you to show your work for that, because I know you can figure out the 7 to the second power is equal to 49 in your head. So I will try to be reasonable, but also if you're not sure, err on the side of showing more work. Okay. That said, let's go through this thing. And if you have any questions, be sure to ask them. Typically, I do like to have a first page like this where you just get to, really this first page is kind of help you remember some of the things you're supposed to know. So log base 3 of 1/9, we can figure out, I think, without, you certainly can show some work, but you don't have to show any work. I know the answer is -2, but if I wasn't sure, I would write down over here or somewhere, log base 3 of 1/9 equals x, 3 to the x equals 1/9, 3 to the x equals 3 to the -2. I will point out I have a personal bias when it comes to logarithms. I'm trying to get over it, but I do have a bias, and I will fully admit I am very, very biased against this. If someone asks you to find log base 8 of say 4, and you write this, log base 2 cubed of 2 squared, and then say the 2's cancel and you get what, 2/3? I don't like it. I know that it's valid, but it just feels like you're not showing a lot of work to me. So if you do something like this, I would really, really encourage you to take another step. So instead of going straight from this to this, I know it's true, I would appreciate it if you did something more like this. Obviously not on this first page. On this first page, you can do whatever you want, because that's it. But here you can rewrite this as 2 to the 3rd to the x equals 2 squared, and then 2 to the 3x equals 2 squared, and then 3x equals 2. That lets me know that you're not just blindly following a rule, which I think is easy to kind of mess up personally. If you've never seen this before, please ignore it. I think it's not wrong. I just don't like it. Again, I said, I'm biased. I'm totally biased against it. It's my own thing. I'm trying to get over it a little bit because I know it's not wrong. It bothers me. I'm sorry. I'm an old math person. I do it the way I like to do it. I'm trying to get past it. Okay, so, but again, show your work, except for on this first page. Second thing here, y-intercept. So we know we find the y-intercept by plugging in x equal to 0. If I plug in 0 for x, I'm going to get 0 plus 0 plus 18 times 1/6. So I'm going to get 3 by setting x equal to 0. I'm showing my work here so that you can see it a little bit, but you don't have to show your work on this first page. Center of this circle. Okay. So is it -5, +11, or is it +5, -11? Right. +5, -11, because we want the things to make this 0. And the radius is the square root of that number that's over there on the right-hand side. Not 7 squared, the square root of 7. Okay. Also, if you guys on Zoom have questions, don't hesitate to throw them at me. Also, everybody here, right? If there's something you want me to say more about, let me know. Vertex of the parabola. So this parabola is written in the vertex form. The idea here is you should not multiply it out and do -b over 2a. We should look at this and say, oh, x needs to be -8 to make this part 0, and then 2 times 0 minus 9, the y value is -9. If you see a parabola written in the vertex form, the vertex is meant to be obvious or easy to see, as long as I write it in a way that you can read it. That's a -8 comma -9. Oh, exact value of log of 10 times the cube root of 10. What is the base here? 10. So it's supposed to be pretty easy, not too terrible. If I was doing this, I would either break it apart into 2 logarithms and say it's log of 10 plus log of the cube root of 10. which is equal to log of 10 is 1. And you might rewrite this as log of 10 to the 1/3 power. So the 1/3 comes down and you get 1 plus 1/3 times log of 10. And log of 10 again is 1. So you get 1 plus 1/3, which is 4/3. Or you could simplify the inside of the logarithm first. And you could say, again, right, I'm showing all the work. You could just, if you know it's 4/3, you can write 4/3 full credit. Or you could say, well, I'm going to write this as log base 10 of 10 to the first times 10 to the 1/3. And 10 to the first times 10 to the 1/3 is 10 to the 4/3. That's log base 10 of 10 to the 4/3. And then that's just 4/3. So that's how I'm, you can think about that kind of either way. Come on in. You got to practice this if you want. In the equation for compound interest, A equals P times 1 plus R over N to the NT power. Interest compounded weekly at an interest rate of 17% would make N equal to how many should N be if we're compounding it weekly? 52. 52 weeks in the year. There are 10 weeks left in this year, by the way. And then what's our interest rate? 0.17. Right, you're just moving that decimal place over 2. 17%, move it over 2. Okay. Rewrite 2 to the x equal to 17 as a logarithmic equation using the logarithm with a base of 2. So we're really just being asked to change this into a logarithmic expression. Our log is base 2 as requested by the problem. And it's log base 2 of what? Is it x or is it 17? Definitely 17. Because the logarithm should equal whatever the exponent was in the previous example. So the log base 2 of 17 should equal the thing that was the exponent, which was definitely x. Okay. Finally, on this first page, true or false? The square root of 5 plus the square root of 4 squared is 5 plus 4, which is 9. And that is 100% false. It is very, very false. I want you all to, this is so much I want you all to know this deep in your hearts. That when you square this out, so if you were to square this thing, well, let me ask you a different question. Something squared equal to 9, what should the something have been? What number do you square to get 9? 3. But the square root of 5 plus the square root of 4 is definitely not 3. The square root of 5 is like about 2 point something. I don't know, 2.3-ish, maybe, probably less. And the square root of 4 is 2. And 2.3 plus 2 is like 4 point something. And 4 point something squared is way bigger than 9. The other way to understand why this is false is if you square something, you don't just square each part, you have to FOIL it out. And if you FOIL this out, it's going to be a lot more than just the first piece and the last piece. You are going to get the square root of 5 times the square root of 5, which is 5. And you are going to get the square root of 4 times the square root of 4, which is 4. But you're also going to get the square root of 5 times the square root of 4, which is the square root of 20. And also, again, the square root of 5 times the square root of 4. So it's actually a whole lot more than 9. It's a lot more than 9. So be careful there, right? When you have some quantity squared, that really just means you're multiplying that whole thing by itself. And then you have to use whatever multiplication rules would apply. In the same sort of way, just so you all know, I often will ask a similar question like, is the square root of 4 squared plus 3 squared equal to 4 plus 3? And the answer is false. Okay. I don't want to tell you what I usually do. Most of the time, that last question I ask is false. Not that, but I shouldn't say that because now I'll probably try to make it true or something. I don't want it to always be the same, but like, just pay attention to that. Okay. So now, the remainder of the problems, you must show your work in order to receive credit. Great. Find a numerical answer for x. I've got log base 5 of the square root of 125 equal to x. So I'm going to do, you could do a couple different things here. One way to go would be to write this as 5 to the x equal to the square root of 125, and then say 5 to the x equals the square root of 125 is 5 cubed, and then say 5 to the x is equal to 5 to the third to the 1/2. So 5 to the x equals 5 to the 3/2. So x equals 3/2. Or you could have done this as log base 5 of the square root of 5 cubed is log base 5 of 5 to the 3/2, which is 3/2. Yeah. There's probably other ways to do that too. Find the equation of the line through the points, -3, 1, and 2, 5. So to find the equation of a line, we need two things. We need a point and a slope. And I will probably clarify this on the exam. I would prefer to write it in the y equals mx plus b form, even though that's not typically the way I start. So a point, we'll deal with the point in a minute. The slope, we're going to use the slope formula. That's going to be the difference in the y's divided by the difference in the x's. So in this case, I'm going to get the difference in the y's, and you can subtract either way. I'm going to do 5 minus 1 divided by 2 minus -3. I'm going to get 4 divided by 5, and that's my slope. You know what's kind of cool about the slope equation? The slope equation also kind of tells you the point slope formula. If you multiply both sides by the denominator, you get y minus y equals m times x minus x. It's totally the point slope formula. So here, that's kind of the way I like to do it, is use the point slope formula. So point slope, we say y minus either y value is equal to the slope times x minus the corresponding x value. So then you just have to pick one of the points. And if I have a choice, I'm probably going to pick the points that don't have any negatives if there is such an option. So I would choose y minus 5 equal to 4/5 times x minus 2. That's the point. I'm picking this point because neither of them happen to be negative and just easier to deal with. And then if we're isolating y, which I will ask you to do, we have y minus 5 equal to 4/5 times x and 4/5 times -2. And if we add 5 to everything, we've got y equal to 4/5 x minus 8/5. And if I add 5, I'm really adding 25/5. So that ends up being y equals 4/5 x plus -8 plus 25 is 17/5. You can do it that way, or you can do it the y equals mx plus b way, where you say, I'm going to start with y equals 4/5 x plus b, and then plug in either point. Again, I'm going to pick the same point. Y is 5, x is 2, and then solve for b. So 5, which is 25/5, equals 8/5 plus b. So b equals 25/5 minus 8/5, which is 17/5. The only reason I kind of prefer doing it this first way as opposed to the second way is because if you do it this first way, you kind of just eventually get the equation at the very end. Whereas the second way, after you solve for b, then you have to go back and plug it back in and say, okay, my equation is 4/5 x plus 17/5. It's not like it's a lot more work, but it just feels like an extra step for me that I would rather not do. Either way, totally fine, totally works. What are you going to do? So I said to myself, I didn't say it out loud. I should have said it out loud. When I added 5 to both sides. So I know I was adding 5, and this is 5, but I said I knew I needed a common denominator. Because I want to add this 5 to this -8/5. And to add fractions, I have to have a common denominator. So I said, oh, I'm going to take my 5, or 5/1 if you prefer, and multiply it by 5/5. So that then it has a common denominator with 8/5, and I have 25/5. That's what's happening then. Same deal over here, right? My 5, I multiply by 5/5, and it was 5/1, and then I got 25/5. Yeah. Okay. Keep going, as there's a lot of questions to get through. Use the properties of logarithms, so you can see that. Property of logs to simplify the expression to a single logarithm and then to a numerical answer. meaning using the power rule, the addition rule, the subtraction rule, sorry, not the power rule, the multiplication rule, the quotient rule, the logarithm. So before you can start simplifying this logarithm, we really need to bring any powers up into the logarithm. So I'm going to rewrite this as the log base 6 of 9 to the 1/2 power minus the log base 6 of 2 plus the log base 6 of 24. Now, here's where I've seen there's a really easy mistake to make that I don't want you to make. These two logarithms don't combine together to make log base 6 of 48. Because it's not log base 6 of 2 plus log base 6 of 24, sorry. It is negative log base 6 of 2 plus log base 6 of 24. And we can't just use the addition product rule as a logarithm. So what I would probably do first is say 9 to the 1/2 is 3. This is log base 6 of 3 minus log base 6 of 2 plus log base 6 of 24. And if I was trying to do this piece by piece, I would probably just combine these first two things first and say, oh, log base 6 of 3 minus log base 6 of 2 is going to be log base 6 of 3 divided by 2. So this part here is log base 6 of 3 divided by 2 plus log base 6 of 24. And now that I have these two logarithms added together, I can multiply their insides. This is going to equal log base 6 of 3/2 times 24. Here's what I would say very generally. If you have a bunch of logarithms added and subtracted together with the same base, all the things that are being added, in this case, the log of 6 and the log of 24, sorry, the log of 3 and the log of 24, those things end up in the numerator. Whereas the things that are being subtracted, the log base 6 of 2, that 2 ends up in the denominator. And that's kind of always true when you're adding and subtracting logarithms together. Is that all the logarithms that are being added, the things that they're the logarithm of end up in your numerator, and the things that are being subtracted, the things that are the logarithm of end up being in the denominator. So simplifying this, we have log base 6 of 3 times 24 divided by 2. And instead of doing 3 times 24, which is a slightly difficult calculation, I would rather do 24 divided by 2, which is 12, and then 3 times 12 is 36. So I've got log base 6 of 36, and that's equal to 2. Right. A slightly less nice problem after it. Solve for x. I've got e to the x plus 3 equals 7 to the 2x plus 1. And so seeing that I have an e to the something, it is definitely a good idea to use the natural log. You can certainly use a different logarithm, but it is generally the nicest to use the natural log because that base will end up going away. So I'm going to write this as the natural log of e to the x plus 3 equal to the natural log of 7 to the 2x plus 1. And then the natural log of e to the x plus 3 is x plus 3. You could say times natural log of e, but you don't have to because the natural log of e is just 1. But I will in this first step here. And then it's going to equal 2x plus 1 times the natural log of 7. Now be careful. This 2x plus 1 over here and this x plus 3 over here, they should both have parentheses around them so that the thing they're being multiplied by will distribute to each of them. It's not going to matter over here because that's just a 1, and 1 times anything is still 1, but it's still important to look at those parentheses. So now we've got x plus 3 equal to 2x times natural log of 7 plus 1 times natural log of 7. And now we're going to group all of the things that have an x on the same side. So I'm going to have x minus 2x times natural log of 7 equal to the natural log of 7 minus the 3 over there. And this is where we have to factor out an x. I'm left with x times 1 minus 2 times natural log of 7 equal to natural log of 7 minus 3. Finally, divide both sides by 1 minus 2 natural log of 7 to get x equal to the natural log of 7 minus 3 for 1 minus 2 natural log of 7. There are lots of equivalent ways of writing this answer. I'm perfectly happy with you leaving it like this. You do not need to bring that 2 up as the power of 7 and write it as like 1 minus natural log of 49. That is not something I need to do. I just need you to be able to get x all by itself. Make sure that when you are getting x all by itself, there aren't any x's in your answer, right? If x is all by itself, but there's it's equal to something with x in it, you didn't really get x all by itself. Notice for both of these questions, well, obviously for the first one, not a big deal, but for the second one, I'm not asking you to find a decimal approximation. No need to use the calculator here. Also, I will point out, you're certainly welcome to take pictures, whatever. These solutions are posted on Canvas as well, so you can totally see them on Canvas if you need to see them. But you're also welcome to take pictures. Totally fine. Cool. And if you've got questions, you should ask them. All right. Solve the following equations. Be sure to check for extraneous solutions. So I've got, oh, I know what else I was going to say. All the quizzes have been graded. First couple homework assignments have been graded. I'm working on grading the last GH and IJ, and we graded it too. They might not get graded all the way before the your test. If you wait till Sunday, they're more likely to be graded. But what I will say is I will post those homework solutions today as well, so that you can look at those even if the homework assignments haven't been graded. But I will try to get them graded by Sunday so that you can see them if you wait until Sunday to take the exam. I've got log base 2 of x plus 9 plus log base 2 of x plus 3. So I'm going to combine those logarithms together as one logarithm where I multiply the insides together. And then I personally like to take the route of first actually simplifying the insides before I do anything else. So I'm going to rewrite this as log base 2 of x squared plus 9x plus 3x is plus 12x, and 3 times 9 is 27. Okay, here is the key step that I know a few of you missed when you were doing this sort of problem on either a homework assignment or a quiz. When you rewrite this, you have to say you have 2 to the 4th equals this inside stuff here. So I have 2 to the 4th equals x squared plus 12x plus 27. Or if you prefer, x squared plus 12x plus 27 equals not just 4, but 2 raised to the 4th power. And then we have a quadratic equation. Whenever we're trying to solve a quadratic, we want to bring everything to one side and then set it equal to 0. I will point out, I think one of the homework assignments where you had a question like this, the solutions were really gross. It was like plus or 1 plus or minus the square root of 13 or something. That was unintentional. I intend to rewrite that problem for future classes. So I'm sorry that problem had kind of gross answers. Sometimes that happens. Still, you still have to check them, even if they're gross. Certainly not usually the plan, but sometimes things don't always go as planned. So looking at this, I got x squared plus 12x. 2 to the 4th is 16, and 27 minus 16 is 11. And this does factor. Factors as, well, there's only really one way to multiply to 11. That's not totally true. There's 2 ways. 1 times 11 or negative 1 times negative 11. But here it's definitely going to be x plus 1 times x plus 11. So our possible solutions are x equal to negative 1 and x equal to negative 11. I do want you to write down both of them so you see that there are 2 possible solutions to this equation, but then we need to check them. If you plug in negative 1 to your original expression, negative 1 plus 9 is positive, we're cool. Negative 1 plus 3 is positive, great, that totally works out. So as long as you're plugging them in and you're taking a log of a positive thing, safe and sound. On the other hand, if you take negative 11, negative 11 plus 9 is negative 2, doesn't work. We can't take a log of negative 2. So that's no good. So our only answer is actually negative. I will remind you, you can totally get negative answers like we do right here. You just can't get negative things inside the logarithm. This next one. There's some big numbers there. I feel like I might have made a mistake when I wrote this one last time, but we'll see. So log base 9 of, so here we're subtracting. So it's not x plus 71 times x minus 1. It's x plus 71 divided by x minus 1. Equal 1. I can't simplify that inside, but there's no multiplying it out. There's no dividing it out. I'm just going to rewrite it as 9 to the 1st power equals x plus 71 over x minus 1. And if you run into something like this, where you've got fractions, I think the first thing you want to do is get rid of the fractions. If there's fractions on both sides, cross multiply. If there's fractions on one side, just multiply both sides by that denominator. So on the right-hand side, the x minus 1s will cancel or divide to 1. So you're just left with x plus 71. On the right-hand side, you have 9x minus 9. I'm distributing 9 to each of those terms. And then I'm going to bring my x's to the side where they'll be positive, even though you can pick either side. So I'm going to divide both, sorry, not divide, I'm going to subtract x from both sides. So I have 8x, and I'm going to add 9 to both sides, which is going to give me 71 plus 9 is 80. And then dividing both sides by 8, I should get x equal to 80 over 8, which is 10. And I still have to check my answer. So I plug back into the original thing. 10 plus 71 is positive, 10 minus 1 is positive. Great. We're good to go. So x equals 10. You do always have to check, even if you only get one answer, because it's possible that you really have no actual solution. All your solutions could be extreme. So every time you're solving something with logarithms, it's always vital that we check our answers to make sure they're really valid. Okay. Let's look at the next one. Ooh, some graphing. All right. Sketch the graphs of the following equations listed below on the same coordinate system. Below, again. Be sure to find all the points asked for below. Can I say below one more time? Okay. So let's think about what we've got. So when we look at y equals x squared minus 2x, we should immediately recognize that that is going to be a parabola, because the highest power of x is x squared. Similarly, when I look at y equals negative x plus 2, we should immediately recognize that's going to be a line, because it's linear. We've got x to the first. Also, the things below each of them are very indicative of what we've got, right? The thing says vertex, oh, it's going to be a parabola. Right? This thing is just asking for the intercepts. Okay, probably a line. So let's find the things. So here for this line, the x-intercept, if I set y equal to 0, I should have written the y-intercept first. Usually we do the y-intercept before the x-intercept. Oh well. So we set y equal to 0, I get 0 equal to negative x plus 2. So x is going to equal 2. So 2 comma 0 is my x-intercept. And then my y-intercept, if I set x equal to 0, I'm going to get y equal to negative 0 plus 2, which is just 2. So my y-intercept is 0 comma 2. For the x-intercepts, you always get the y part being 0. For the y-intercepts, you always get the x part being 0. Let's do the same thing for the parabola over here. So let's find the y-intercept first, because that's more typical. Y-intercept, you're going to set x equal to 0. You're going to get y equal to 0 squared minus 2 times 0, which is 0. So 0, 0 is my y-intercept. I also know it's going to be one of my x-intercepts. Right? If the origin is an intercept, it's a y and an x-intercept. So great. Solving for the x-intercept, I've got x squared minus 2x equal to 0, and we should factor. When I say factor, I mean kind of a lot of things. Here, before you try and do any like the fancy, x minus 3, x plus 1 kind of stuff, just see if there's any kind of greatest common factor you can factor out. And there is. We can factor out an x. So x times x minus 2 equals 0. You're going to get x equal to 0 and x equal to 2. So our intercepts are 0, 0, and 2 comma 0. Finally, what we probably should have done first for the parabola was find the vertex. So for the vertex, we find the x coordinate first. We're going to say that Vx is negative b over 2a. Our b value is negative 2. And our a value is positive 1. So we end up with 2 over 2, which is 1. Y coordinate of our vertex, we just plug that 1 back into the parabola, and we get 1 squared minus 2 times 1, which is 1 minus 2, which is negative 1. So our vertex is the point 1, negative 1. And I guess we should find the intersection points before we graph. Although I might start graphing things a little bit. So here's what I would say. This might be helpful if you're doing this on the exam. You might use different colors for each graph. You don't have to. I would. So my parabola, I've got the points 0, 0, and 2, 0. And I've got the vertex 1, negative 1. Oh, good. It's opening upwards like it should be, right? And then for my line, I've got the points 0, 2, and 2, 0. So I've got this point here. And that, oh, I already found a point of intersection just by looking at the graphs. Oh, nice. The line's pretty easy to graph. You might just graph it right away. So looking at this, it looks like we're going to have a point of intersection somewhere over here in this second quadrant. But let's actually find it. And the way you find the intersection points is by setting each equation equal to the other equation. So set the first equation equal to the second equation. And bring everything over to one side. So bringing everything over to the left, I've got x squared, negative 2x plus x is negative 1x, and minus 2. And then we're going to factor. We're going to get x minus 2 times x plus 1 equal to 0. So we're going to get x equal to 2, and we're going to get x equal to negative 1. Now, to actually find the points fully of intersection, we have to find the corresponding y coordinate as well. One of them we already know. We know that if x is 2, that's one of our intercepts. We know one coordinate is the point 2, 0. The other one, if I plug negative 1 back into either equation, either this one or this one, I should get the same thing. If I plug in negative 1 here, negative 1 plus 2 is going to give me 3. And just to check if you really wanted to, although you don't have to, plug in negative 1 here, negative 1 squared is 1, minus 2 times negative 1 is plus 2, which is 3. So our other intersection point is the point x is negative 1, y is positive 3, which is right about there. And then we can draw our parabola as best we can. Do your best, doesn't have to be perfect. Ta-da. Okay. Someone asked, just to clarify, no graphs of logarithms or exponential functions on this. We haven't even talked about those in class yet, so they definitely will not be appearing on the exam, but just to clarify that question I received via email. All right, let's look at some exponential growth. Bacteria, the bane of existence, are growing, not really, I mean, they help us out a lot. Bacteria are growing exponentially, as we would expect. There are 100 present initially and 600 present 5 hours later. Okay, if you read that sentence, stop. Write down the little table thing and what that means. So on my little table over here, I've got time and I've got the amount, and I know initially, meaning at time equal to, I have 100 bacteria. And 5 hours later, I have 600 bacteria. Right there, we have all the information we need to find our C and our K in our model, y equals C e to the KT. We have everything. So, in fact, I might just do that first, because you know you're going to have to do that. When you're doing this exponential growth kind of thing, you're going to have to find C and K for this model. C is pretty usually straightforward. C is going to be 100 here because it's the amount we have at time zero. You can also do the work, right? If you're not sure about C, plug in this first thing and see, okay, well, y is 100 and time is 0. And now if I solve, well, k times 0 is 0. And anything to the 0th power is 1. So C has to equal 100. You don't need to show any of that work to find C, but you certainly can if you want to. But finding C is usually just a given. On the other hand, finding K is not a given. We have to do some work to find K. So now plugging in this to our refined model, where we now have plugged in C equal to 100 already, we have y is going to be 600 equal to C, which is 100, times e to the k, which we don't know, and we're plugging in 5 for t. And then we're going to solve for k. And the process is pretty standard. First, divide by whatever that c value is. So divide both sides by 100. So 600 divided by 100 equals 100 e to the 5k divided by 100. Those cancel. 600 over 100 is 6. And then after we've gotten rid of that coefficient on the right side, we can take the natural log of both sides. So we're going to have the natural log of 6 equal to, you can write the natural log of e to the 5k, or you can just jump to saying it's 5k. I'm going to write the natural log of e to the 5k and then say, oh, that's just 5k. And then solving for k is going to equal the natural log of 6 divided by 5. So now our fully fledged complete model is y equal to 100 e to the natural log of 6 over 5 times t. Just, I will point out, so I'm going to say something that if it doesn't sound familiar to you, just ignore it. But you might have learned a different way of doing this in the past math class. You might have learned that, oh, if it takes 5 hours for this to multiply by 6, then I could also write this as y equal to 100 times 6 to the t over 5 power. That is another way that sometimes people do this. I have never really done it that way, but it totally works. So if you do it this way instead, that's a perfectly fine way of getting there. And you kind of avoid all this. If this looks like bizarre to you, ignore it, right? It's not, you don't have to do it this way. But I just want to say, if you've done it this way before and you like doing it this way, that's totally fine. So then, then we should finish reading the question. So, how long will it take the population to triple? Please give both the expression for the exact answer, which will have logarithms in it, or potentially not, I guess, if you do it this way, and the decimal approximation. So to 1 decimal point. All right. So if I want to know how long it takes for the population to triple, I want to know how long it takes till I get to how many bacteria. I can't quite hear you guys. So good. I'm glad somebody said that. So it's actually not 1800 because I'm not asking how long it takes to triple from here. I want to know how long it takes to triple from the beginning. So typically, if someone ever says how long it takes to triple, double, quadruple, whatever, it's always from the initial period. Now, I will say you could do 1800, but the thing is, then you have to subtract out 5 from your answer because you're saying how long it takes to triple from this moment here. So it's going to be easier if you just say, well, from the beginning, I'm going to find out how long it takes to get triple of what I started with. So I want to know how long it takes to get to 300 bacteria. It's not going to be 2.5 hours, right? It's not just half the time because we're getting half of 600. We have to plug it into the stuff. So setting y equal to 300, we got 300 equal to e 100 e to the natural log of 6 over 5 times t. So then we divide by 100. So not surprisingly, we get 3 because it's triple equal to e to the natural log of 6 over 5 times t. And now our job is to solve for t. So take the natural log of both sides. The natural log of 3 equals the natural log of e to the stuff, which again, you could skip writing the natural log of e to the stuff and say it's just going to be that part up there. Then we have the natural log of 3 equal to the natural log of 6 over 5 times t. Solving for t, we get t equal to 5 times natural log of 3 divided by natural log of 6. And I didn't bring my good calculator with me, of course, so I have to do it on my janky phone calculator. Definitely encourage you to have a more reliable calculator than your phone calculator. But doing it on my phone, let's see, I always hate doing logs on my phone because so I'm gonna do the natural up. So you can't take the natural log of 0, right? That's always the problem here with your phone, right? For your phone, for a logarithm, you have to enter the 3 first and then take the natural log of it and then multiply it by 5 and then divide it by, and here's where things get tricky. You have to use 6 and then the natural log. So there's the natural log of 6, and now I'm dividing by it to get about 3.06. So my answer should be rounded to the first decimal place, about 3.1 hours. Don't use the phone calculator for doing this. I mean, you can, obviously, it's possible, but it's easier to use a more normal calculator. So do what you want. Yeah. Okay. How much money do you need? All of it. How much money do you need to deposit in a savings account earning 5% interest compounded monthly to have $10,000 after 3 years? Okay. So I just read all that stuff. I'm going to write down all the things I need. So first of all, we are in the compound interest situation, and it's not compounded continuously, it's compounded not continuously. So I know we're using this formula. The amount of money after T years is P times 1 plus R over N to the NT power, which is written on the front of the exam. All right, so now we have to identify all the things. So let's see here. I know that my interest rate is 5%, which is 0.05, or if you prefer 0.05 to make sure there's a 0 between the decimal and your number. I want to have $10,000, meaning I want P to be 10,000 or A to be 10,000. A, right? I want the amount of money I have to be 10 grand, meaning my answer should be less than that. Right? If I want to have $10,000 in 3 years, I shouldn't be having to invest more than $10,000 to get that, unless the market's doing really bad. Or interest rates are going negative. So the point is that the thing we're going to find here should be less than 10. What else do we have? We have time equal to 3 years. And what else do I need? I need N. What should N be? 12, because we're compounding monthly. So then we're just going to toss all this into the formula. We've got 10,000 equal to P times 1 plus 0.05 divided by 12 to the 12 times 3 power. I'm going to simplify this a tiny bit. I'm going to write this as 10,000 equal to P times 1 plus. This doesn't really simplify, so I'm just going to leave it as is. 0.05 divided by 12. 12 times 3 is 36. Unlike having to solve for like T here, there is no need to use a logarithm. All we have to do is divide both sides by this thing here. 1 plus 0.05 divided by 12 to the 36 power. So then we're going to get our expression is that P is equal to 10,000 divided by 1 plus 0.05 divided by 12 to the 36 power. And that's honestly the part I care more about. But it's not particularly meaningful, so we get a decimal approximation. And again, oops, I made a mistake here. It's not a big one, but my 10,000 turned into 1,000, 100. Make sure you get all right. I'm gonna lose that. And then phone calculator. We'll get the phone calculator. So if I was going to calculate this, I would do the bottom part first. Would I do the bottom part first? Maybe. Yeah. I wouldn't use these. So yeah. So I've got 0.05 divided by 12 plus 1. And then I'm going to raise that to the 36th power. And then I'm going to do 10,000 divided by that. So if I'm stuck with the phone calculator, I'm probably going to write down a bunch of decimal places here. 1.16147223 1. Yeah. And then I'm going to do 10,000 divided by that. There's not like an answer button here. Disappointing. Anyway, 1.1. Whoops. Now I'm screwed, right? So I'm going to do 10,000 divided by, See? Here's a really good example of why you should not use the phone calculator. It takes more time. If we do it, we get about $8,609. And we wanted, let's see, 2 decimal places. So about $8,609.76. I'm not too much of a stickler for getting, like, if you're off by a little bit with your approximation, totally fine. What I do care more about is that you actually give the correct number of decimal places. If I ask for 2 decimal places, give me 2. If I ask for 1, give me 1. If I ask for just if I ask for like the nearest dollar, we should round to $8,610. Some optimization. Find the dimensions of the largest rectangle in first quadrant that can be inscribed under the line y equals 18 minus 2x. And even though you might have seen this enough times to know that if this intercept is 18 and this intercept over here is 9, that the x and the y value are kind of half of those intercepts. So I know from experience, I'm going to get an answer of y equals 9 and x equals 9/2. You still have to show the work. So let's draw our rectangle that we're trying to make as big as possible. I'm going to make it not look as big as possible. There's our rectangle. We don't know the dimensions of the rectangle. So I'm going to call this side the width and this side the height, or x and y, or whatever is used. And I know that this coordinate here, which is over w and up h, lives on that line. So if I'm trying to maximize the area is equal to w times h. But wh, the point being on this line, means that my constraint is that while h is the y thing, w is the x thing, it means that h has to equal 18 minus 2 times w. Oh, I'm sorry, you can't see what I'm saying. Right? Our line here, right? This is the line y equals 18 minus 2x. So I'm just subbing in w for x and h for y. And then I'm going to take that, put it right there. So now my area can be written as a function of one variable, w times 18 minus 2w. And then we multiply it out. So we have, so I'm going to write it kind of the wrong way first. It's not wrong, just not convenient. It's probably a good idea to write it in the standard way, meaning your highest powers first. So negative 2w squared plus 18w. Then we find the vertex. Our input, which is the w thing, is negative b over 2 times a, which is not lovely, but it's fine. It's 18 over 4, which reduces to 9 over 2, or if you're a decimal kind of person, 4.5. And then after you find the first half of the vertex, that's when you want to go back and read the question. So go back and read the question. The question says, find the dimensions of the largest rectangle. It does not say find the area. So I don't want to plug this back in here and find the area, which would be the other half of the vertex, the y coordinate. I don't want that. I don't need it. No one's asking for it. You can totally find it, but it's not worth anything here. On the other, so what we're going to do instead is we're going to plug this back into the constraint and say, oh, well, if I know that my width is 4.5, my height is going to be 18 minus 2 times 4.5, or 2 times 9/2. And then the 2's cancel, and you get 18 minus 9, which is just 9. So those are your dimensions. Height is 9, width is 4.5. It is 10:50. So you're obviously welcome to go if you need to go. I mean, you're welcome to go anytime, right? Like, you never have to stay. I'm going to do this last problem just so those of you who want to see it can see it. It will only take a moment here. Extra credit. Find two numbers that add up to 10 so that the sum of twice the square of the first number and 3 times the square of the second number is maximized. I don't love this question just because we haven't really done a lot of these like this in class. So if there's an extra credit question, it probably won't be like this. But just so you can see, it's just another optimization problem. We want to maximize, well, let's see, let's call our numbers x and y. We're trying to maximize twice the square of the first number. So twice the square of the first number and 3 times the square of the second number. And we know that the constraint is that they have to add up to 10. So then we take this constraint and we solve for one of the variables, and then we plug that into the thing we want to maximize. So we're trying to maximize 2x squared plus 3 times 10 minus x squared. And I think I've asked a bad question here, actually. So let me point out, so we'll go with this for a second here, just to kind of point out, but I want to show you that, so sometimes I make a mistake. It may happen once or twice or more. This is actually a question that doesn't have an answer the way I've asked it. Let me show you why. So if we keep going here, this is 2x squared plus 3 times, if I multiply this out, this is 100 minus 20x plus x squared. If I keep going here, this is 2x squared plus 300 minus 60x plus 3x squared. And simplifying this is 5x squared minus 60x plus 300. Now let me ask all of you. Which way is this parabola open? Up or down? Up, which means it has a maximum or a minimum? A minimum, and I asked for a maximum. That's the mistake. I actually gave that. None of my students pointed this out when I gave this test last year. So what I should so I will say a lot of times people just, you should all try the extra credit question. It may be a little harder, or in this case, kind of impossible. But it's usually not meant to be. I usually don't ask impossible questions. What I will say is definitely try the extra credit. It's just another question. It's worth points. So what I should have asked here is, we want the sum to be, we want this thing to actually be not maximized, but minimized. That was what I meant to have asked. Ugh, terrible. So then if we want to minimize this, we find the vertex. Vx is going to be negative b over 2a, which is negative 60 over 2 times 5, which is 60 over 10. And then the y, so that's going to be my x value. And then the y value is going to be 10 minus 6, which is 4. So those two numbers, x equal to 6 and y equal to 4, would minimize this possible sum here. But it is not possible to maximize that under this constraint.